Good morning, guys. I am so excited that these technology updates here on campus means that all of our videos should be such better quality. If you'll notice, instead of me videoing my screen, it's right to my notebook. So you should be able to see things much clearer. So jumping in with lesson 17. Now notice I didn't do 16, and I didn't do 16 for a reason. It's difficult. No one ever uses it, so we're going to skip it, okay? And I'll put that in the notes. We are skipping lesson 16. And I hope you guys are watching these videos. If not, I'm going to start making them a requirement. So please watch these videos. So today's section is on solving equations and inequalities with absolute value. Now remember, absolute value is the distance from 0. So because it's about the distance, our answers cannot be negative, right? It has to be a positive value because you can't have a negative distance. Also, we are going to have to set up two equations for each problem. And I'm going to go over that just starting to begin with. So if I give you solve the absolute value of x minus a equals k, you're going to set up two different equations to solve. One would be x minus a equals k, and the other would be x minus k, x minus a, my apologies, equals a negative k. So you would set up two equations to solve your problem. So you're going to have to do that. Notice I have one with positive k, one, the big change, you make that right-hand side equal negative 2. Also, it is possible to get something called extraneous solutions. And those are solutions that do not work. So solutions that do not satisfy the original equation. So here we go. We're going to jump in. We're going to do a couple examples. So solve the absolute value of x minus 6 equals 4. So the first thing I'm going to do is set up my two equations. So x minus 6 equals 4, and x minus 6 equals a negative 4. And then we'll solve for both. So the first one, right, I would add 6 to both sides. X equals 10. The next one, if I add 6 to both sides, I get 2. And both work. So I would check both. The absolute value of 10 minus 6 equals 4 works, and the absolute value of 2 minus 6 equals 4 because you get negative 4, and the absolute value of negative 4 is 4. So my two answers are x equals 10 and x equals 2. Next one, solve the absolute value of 3x plus 5 plus 12 equals 2. Now the first thing I have to do is I have to isolate the part that has the absolute value. So anything before or after it has to be moved. So the first thing I have to do is move that 12. So I'm going to subtract 12 from both sides, and I'm going to rewrite my problem. So I get 3x plus 5 equals a negative 10. Now, I am going to now set up now right when I look at this, I'm like, whoa. How can I have the absolute value to equal a negative number? Absolute value means distance. My distance cannot equal a negative 10. So there is no solution in this one because the absolute value of 3x plus 5 cannot equal a negative number. So this problem, the answer is no solution. Next one. Solve 2x plus 4 minus 5 equals 1. Now remember, I have to get this part here by itself. So the first thing I have to do is move that 5. So I'm going to add 5 to both sides, and I get 2x plus 4 equals 6. Now I hope you can see the difference between this problem and the last one. This is saying the absolute value, or the distance of 2x plus 4, is 6 units away from 0. And this is possible because the distance is a positive 6. Now when I write my two equations, 2x plus 4 equals 6, I'm writing it as an equation. There is no absolute value. So that's why it can equal a negative 6. So we rewrite our two possible equations and we solve for both. So on the left, I'm going to subtract 4. I get 2x equals 2. That gives me x equals 1. Now I'm going to subtract 4. I get 2x equals negative 10. So x equals a negative 5, right? When I divide by 2, I'm going to get a negative number. So x equals 1 and negative 5. So you could also write it like this, x equals 1 comma negative 5, okay? So you can write them separate or together. Okay. Moving on. So we're going to do two more. These are going to be our inequalities. So I believe we are on example 4. And I'll do one more. Solve, that's an equation, and then we'll do some inequalities. 3x plus 18 equals 6x. So remember, I have to write two equations. I have to write the equation 3x plus 18 equals 6x, and 3x plus 18 equals a negative 6x. I'm going to solve for both. So 18 equals 3x, so x equals 6. This one I would do the same, subtract 3x. 18 equals negative 9x, divide by negative 9. And x equals a negative 2. Now, I'm going to check this answer. So 3 times negative 2 plus 18 equals 6 times negative 2. Now, if I simplify this, I get negative 6 plus 18. The absolute value is going to equal negative 12. Remember, if I have an absolute value, that's distance from 0, and the distance from 0 cannot equal a negative number. So negative 2 does not work. So only x equals 6. So this is not a solution because it produces a negative value on the right-hand side. So x equals 6 is the only solution. So moving on to our inequalities. So you'll notice the difference in these, x minus 5, the absolute value of x minus 5 is less than or equal to 2. Now, the two different equations here are going to look different. Okay, so the first equation is x minus 5 is less than or equal to. The next one I'm going to make to negative, and I'm going to flip the symbol. Or sorry, I should flip the inequality, and not just put symbol. And flip the inequality. So this is going to be x minus 5 is greater than or equal to negative 2. So notice I changed both. So in an inequality symbol, you not only make this value negative, you also flip your symbol. So now I'm going to solve these inequalities. Add 5. So x is less than or equal to 7. Okay. This one I would add 5. And I get x is greater than or equal to 3. And then I'm going to graph. So here are my solutions. And I'm going to graph it. Remember, these are on a number line. So if this is, I'm going to do 8, 6, 4, 2, 0. So x is less than or equal to 7 would point this way. And this says x is greater than or equal to 3. So there would be the graph. Okay? All right, moving on. Next one. Solve and graph 2x minus 5 is greater than 9. So here we go. You can pause and set up your equations. One is 2x minus 5 is greater than 9. One is 2x minus 5 is less than negative 9. Notice I changed both the inequality and the number. So add 5 to both sides. That would give me 2x is greater than 14. Divide by 2 and x is greater than 7. I would add 5 to both sides. 2x is less than negative 4. So if I divide by 2, I get x is less than negative 2. So on a graph, again, this is just a number line. We don't have x and y. And so if I make this 0, 2, 4, 6, 8. Label it however you want. Now, these should be open. X is less than, remember less than is to the left. And x is greater than 7, and it should be, both of them should be open because there's not an equal to. Okay. So let's now do our lesson practice. And I don't have the page in front of me, but it is in your book, so lesson 18 if you want to pause it and go find it. I don't have the book next to me. I apologize. So lesson practice. So part A says to solve x plus 3, absolute value of x plus 3 is equal to 7. So my two equations are x plus 3 equals 7 and x plus 3 equals a negative 7. All right, I'm going to subtract 3 from both sides, and I get x equals 4. I'm going to subtract 3 here, and I get x equals a negative 10. And both of those work, so my solutions are, you can write it as x equals 4 and negative 10. So if you just want to write it once, you can circle them individually or you can circle them together. It's really your choice, so you decide what works best for you. Next one, solve 3x minus 3 plus 5 equals 8. So again, the first thing I have to do here is isolate the absolute value. So I get the absolute value of 3x minus 3 equals 3. Write my two equations. 3x minus 3 equals a negative 3. 3x minus 3 equals 3. So I would add 3, that would give me 6. Divide, that would give me 2. Add 3 would give me 0. Divide by 3 would give me 0. So my two values are x equals 2 and x equals 0. Next one. The absolute value of 7x minus 2 equals a negative 8. You cannot have the distance of a value equal a negative number, so there is no solution. D, 4x minus 1 equals 2x. Set up your two equations. 4x minus 1 equals positive 2x. 4x minus 1 equals negative 2x. So solving here, I'm going to subtract 4x, and I get negative 1 equals negative 2x. Divide by negative 2, and x equals 1/2. I know this one will work because it's positive, so if I plug it in here, 2 times a positive number will give me a positive number. So if I subtract 4x here, I get negative 1 equals negative 6x. Negative 6 and negative 6 gives me a positive 1/6. And because it's going to be positive, I know that it could work. All right, we have quite a few more. E, x plus 2 is less than 8. So my two equations are x plus 2 is less than 8 and x plus 2 is greater than negative 8. Remember, I have to change both when it comes to an inequality. So if I subtract 2, x is less than 6. If I subtract here, it's greater than or equal to, or greater than negative 10. And my graph doesn't have to be perfect. So let's say this is negative 10. 8, 6, 4, 2, 0, 2. Well, not quite, huh? Space it out however you like. So x is less than 6 and greater than 10. So it would look like this. All right, next one. I'm going to do 3 more. So f, 3 times the absolute value of 5x minus 6 is less than or equal to 6. This one's very important. I'm going to have to do a lot of work till I isolate that 5x. So first thing is first, I add 6, so that gives me 12. Now I have to divide by the 3. So I get the absolute value of 5x is less than or equal to 4. My bad. And then I can write my two equations. 5x is less than or equal to 4. 5x is greater than or equal to negative 4. Now for this one, I'm dividing by 5, so both of my both of my answers are going to be fractions. So x is less than or equal to, and if you want to make these a decimal, you can, but it just means my number line is going to be in fifths. And I'd like you to keep it in fractions. Don't be scared of them. So on a number line, if I made this 0, and I had, this is 2/5, 4/5, right, this would be 6/5, and the opposite direction would be negative, and so forth. So I have an equal to, so these are both solid. It's less than but greater than that, so again, it's in the middle. Part G, the absolute value of negative 2x plus 9 is greater than or equal to 7. So write your two equations. Negative 2x plus 9 is greater than or equal to 7, and negative 2x plus 9 is less than or equal to negative 7. Notice I changed both. Subtract 9. Negative 2x is greater than or equal to negative 2. Now, tricky. When I divide by a negative, I have to flip the sign. Okay, notice this is, you have to flip when dividing by a negative number. So there's one answer. Subtract 9, and I get negative 2x is less than or equal to negative 16. Again, I'm dividing by a negative 2. So x is greater than or equal to 8. So on a number line, So I have a solid at 1 and a solid at 8. And for this one, it says it's greater than 8 or less than 1. Last one that I'm going to do is H. A negative absolute value of 2x plus 3 is less than or equal to 5. Now, you cannot leave a negative right there. So I have to divide both sides by a -1. So divide by -1. And that gives me the absolute value of 2x plus 3 is less than or equal to a -5. And because it's negative, there's no solution. And that finishes our lesson. So hopefully that came in so much clearer than the other videos. Goodbye.